Hello, this is Diganta from Fractions Hub. Today we'll be doing a number theory problem using principle of mathematical induction. Let's go right into the problem. So the problem goes as follows. Show that for every positive integer we can write it as a sum of one or more numbers of the form 2 power r times 3 power s, where r and s are non-negative integers. And no entry in the sum divides another. Okay. So this is the problem. So what it basically says is, say, suppose we have some number, for example, say 23, then it can be written as 3 square, which is 9. That is 2 power 0 into 3 square plus 2 cube times 3 power 0, that is 8, plus 2 into 3, that is 6. Right? Similarly, you can try it out for other numbers like 2, 3, and 4, 5. These are all trivial. 5 is 2 plus 3. 6, 2 into 3, 7 is 2 square plus 3, and so on. Right? So these are examples. So we need to prove that every positive number can be written like this. So we'll be trying to use principle of mathematical induction here. So let's dive right into the proof on how we can show this. Now, as we know, for mathematical induction problems, suppose we can already construct a set Sn with the following properties. One, each element of Sn is of the form 2 power r times 3 power s. R and S are non-negative. 2, no element of Sn divides another. 3, the elements of Sn add up to n, right? Sorry. So you can easily find what is S0, right? So S0 is 5. It doesn't have anything. S1 is 1 itself. And we had seen like some other examples here, right? So these all, so like S23 we had, right? 986. Each element is of this form. No element of Sn divides another. The elements of Sn add up to n. These properties hold here. Right? Now, we assume that for k less than n, we have the desired sets Sk. So, in order to proceed, let us divide n into two parts. That is two cases, even and odd. So, if n is even, then Sn is equal to twice of A, where A is the element of, just a sec, where A is the element of Sn by 2. So the elements of this set don't divide each other, they add up to n by 2, and each element of them is of the form 2 to the power r times r to the power s. So this is the valid construction. So with all the properties we need. Now, if n is even, we are done. If n is odd, we need one more construction. Like, so let us take n to be greater than or equal to 3 power t, where this t is as large as possible. So essentially, this is Vp of 3, that is highest power of 3, Vp, where this is some p less than n. So let me avoid this. So let me just write it down. Highest power of 3, which is below n, which is below n. So we take that as 3 power t. So we construct Sn as follows. So we include 3 power t, and the remaining part would be what? N minus 3 power t. So we need to sum it up. So intersection, union, 2a. So just keep in mind, what we are doing is we have this remaining, n is odd. So our even construction will work. So essentially, when we had the even construction, this would eventually give the odd construction, right? So this is the even part. So let us get back. So this part is what? Where A belongs to the set S n minus 3 power t I 2. Let me keep this in brackets. Okay. So we are not done here totally, because we still need to show that property 2 holds. We have ensured 1 and 3 holds. So in order to check 2, see that 2 holds trivially here, since we are multiplying by 2, and Sn had the desired properties. This had the desired properties. And here we have three power t and n minus 3 power t by 2. So this thing is less than 3 power t, right? So 3 power t is not an issue. That means it is not dividing any other element. And the remaining elements have the following form, right? 2a. So these are even elements. And this is the only odd element. Implies 2 also holds. So Sn can be constructed from Sk, where k is less than n, having all the desired properties. Hope you guys liked it. That's it for today. Thank you.